A lot of you have been asking for me to solve this exact limit on YouTube. And so we're being asked to find the limit as x goes to infinity of root of x plus root x minus root of x minus root x. Now, just be warned that when you put this into generative AI or ChatGPT, which you shouldn't do, ChatGPT got it wrong twice before actually finding the correct answer. So if you didn't get it right in your first two attempts or first attempt, then you can say that you're on AI's level as far as it goes. And if you solved it in one attempt, then you can say you're smarter than AI. So go ahead and try this on your own, but we're going to get right into it. Now, there's going to be a lot of different little intricacies involved in solving this limit, so there are going to be a lot of steps, and I'm going to try and explain every single one of them. And because it's going to take a while, I am going to use a different type of notation for a limit that I've developed so that it's a lot faster to write. So you have the L, a curly L, as x goes to a value c of f, which just means the limit as x goes to c of f. So that's just a little warning of, don't worry, it's just the same thing as saying limit as x goes to infinity, but yeah. Alright, so let's get started. We see these roots here, and we know that if we try and plug in infinity, we don't really see much, and because the root kind of obscures the relationship of how fast these two functions grow, we can't say it's 0 for sure, we can't say that it's going to be infinity for sure, so we have to do a bit more manipulation. So what we're going to do is we're going to multiply both top and bottom by the conjugate, right? The conjugate of root of x plus root x minus root of x minus root x is simply just the plus instead of the minus. So we're going to do that. We're going to say root x plus root x plus root of x minus root x. And we're going to put the same thing on the bottom. I'm just going to reproduce this below so that it's going to be a lot easier to write. We want to save as much time as we can. What just happened? There you go. All right. Now that we've done this, notice that because you multiply something by a conjugate, so z times z conjugate, right, is just going to be the difference of squares of those terms. So what we're going to do is we're going to expand that. So we get the limit as x goes to infinity. And remember that if it just has infinity without a sign, by convention it means positive infinity. So again, these become this term plus times this term minus this term times this term. So the roots really fall out and as a square. So we get x plus root x minus, and now be careful to factor the negative 1 in. So you have minus x, and since you have a negative root x here, to take that negative 1 and put it in, so you have plus root x. And we divide that by the original denominator. So we're going to put that in like that. All right. Now, what do we do from here? Well, now you can see that we already got some cancellation, which means we're going in a good direction. Take these x's and get rid of them, and you can consolidate these two root x's, and so we can get the limit as x goes to infinity of 2 root x divided by the bottom term. So I'm going to just put that bottom term over there. Okay. Now, what do we do next? Well, we see root expressions over here, and we see an x inside of each of them. So what if we can take out this root and factor it and cancel it with the top? Maybe we can get a bit closer to a clearer answer, a convergent answer then. So let's do that. So how do you factor root of x plus root of x? And root x minus root x for that matter? We can say that this is the same thing as root of x times 1 plus 1 over root x. Now, why is this possible? Because when you distribute the x into the 1, you get x. And if you multiply x by 1 over root x, you get x over root x. And how is that equal to root x? We'll multiply by root x to rationalize the denominator, and you see, in fact, that you get x root x over x, which just turns out to be root x. And so, in fact, this does work. So, which means we can factor both the two terms in the bottom as x times root of x times 1 plus 1 over root x, and x times 1 minus 1 over root x, like this. So let's put that in. So this is the same thing as saying the limit as x goes to infinity of 2 root x divided by root of x times 1 plus 1 over root x, right, plus the square root of x times 1 minus 1 over root x. I forgot to close parentheses here. All right. So now, this is going to be equal to the limit as x goes to infinity of, and now I can factor and take out the root x in each of these expressions and create a kind of reverse distributive property. So we get 2 root x on the top, of course. That's a horrible 2. Here, 2 root x on top, and you factor out the root x, and what do you get? In the parentheses, you see we're left with the square root, right? Don't forget the root is the same here. So you have 1 plus 1 over root x plus the square root of 1 minus 1 over root x. All right? And remember, if you want to be sure of this, you can just multiply the root x back and see the original expression. But this is great news for us because we can now cancel out the root x's in top and bottom, and now we have 2 less terms to work with. So now this is the same thing as putting the arithmetic of limits into place. We can take limit as x goes to infinity and throw it into the numerator and denominator by the quotient rule. And if you can visually imagine the square root of 1 plus 1 over root x, you'll see that as x goes to infinity, these terms will go to 0. So we should get something like square root of 1 plus 0 plus square root of 1 plus 1 minus 0. So we get root of 1 plus 1, which is 2. And so you get 2 over 2, which should equal 1. So let's see if that's true using every single step as meticulously as we can. So this is going to be equal to, and this is where I'm going to use my compact notation. So the limit as x goes to infinity of 2 divided by the limit as x goes to infinity of this expression here, which is going to be root of 1 plus 1 over root x plus the square root of 1 minus 1 over root x. And of course, by the sum rule of limits, you can rewrite this as, well, this becomes 2 by the constant rule of limits. So you can see it's just 2 over the limit as x goes to infinity of the square root of 1 plus 1 over root x plus the limit as x goes to infinity of the square root of 1 minus 1 over root x. All right? And now, remember that because the square root is going to be defined as a function from 0 to infinity like this, right? And since we're looking at x near infinity, the root will be continuous near infinity, which means that we can throw this limit under the root. Remember that the power rule for limits only works for integer powers of n. But yeah, anyways, let's do that. So we have 2, and we can just throw that limit under the root, and so we get the root of the limit as x goes to infinity of 1 plus 1 over root x plus the limit under the root, of course, as x goes to infinity of 1 minus 1 over root x. And of course, you can see here that the sum rule can work out over here, and the difference rule works out over here for the limits. So we can say this is the same thing as saying 2 divided by the square root of, well, limit as x goes to infinity of 1 plus limit as x goes to infinity of 1 over root x plus the other root expression, which is going to be the limit as x goes to infinity of 1 minus the limit as x goes to infinity of 1 over root x. Now, of course, we know that this is going to be equal to 1, and this is equal to 1 because they're constants. So we get equals 2 over the square root of 1 plus, and then we're going to add the other side. There's a reason I'm leaving this gap open here, 1 minus, because I'm going to use 2 steps now. The limit as x goes to infinity of 1 over root x, well, notice that 1 over root x is the same thing as root of 1 over root of x, which is equal to the total root of 1 over x, which means that if we have that limit going into the root, we can throw the limit under the root like this again, which means that's exactly what we're going to do. So we're going to say 1 plus the square root of the limit as x goes to infinity, so bear with me here, of 1 over x. All right, and then on the other hand, we have 1 minus the square root of the limit as x goes to infinity of 1 over x. And now we know what the limit as x goes to infinity of 1 over x is, right? As x goes to positive infinity, we see that the 1 over x goes to 0. Plugging in massive numbers in the denominator and dividing 1 by that is going to essentially give you closer and closer values to 0. All right? Which means that we can just take this and plug in 0 for this value, because we already know what the limit as x goes to infinity of 1 over x is. And I encourage you to use epsilon delta proof to show that that's true. But anyways, root 1 plus the square root of 0 here, plus the square root of 1 minus 0, or the square root of 0, technically, if we want to be systematic about it. And that's equal to 2 divided by, well, that's going to be 0, and that's 0, so it doesn't matter. Root 1 plus root 1, which is obviously equal to 2 over 1 plus 1, which, as you know, should equal 2 over 2. And then we get our grand final answer of 1. And that's right. The limit on top here, the limit as x goes to infinity of root x plus root x quantity minus the quantity root of x minus root x, right, is equal to 1. Which is not an obvious result. You have really no way of predicting that that's the case. Because it doesn't, first of all, how would you even graph this? And second of all, it just doesn't make sense, you know? If anything, 0 would seem to make more sense. But in fact, the little differences inside roots and outside of roots is really important for limits at infinity. And that's why roots are so kind of tricky to work with in the first place. So anyways, I hope that this gave you a better and full clear solution of how to do this limit and how to justify every single step. Now, of course, I do not encourage you on an exam to write out every single one of these steps for these kinds of problems, because you're going to waste way too much time. Instead, if you know how to justify them and briefly mention some justifications, that's probably going to be good enough. But remember, let's review what we did. First of all, we multiplied by the conjugate to get rid of these roots. Remember, in general, with any roots, even if these roots didn't exist here, it may be a not bad idea to multiply by conjugates. But anyways, what we get is we cancel out top expressions, and then what we do is we notice we have a root x on the top and a root x on the bottom, and we can factor those out. And when we factor them out, we can take the limit as x goes to infinity of the top and the bottom, and we see that those terms in the denominator go to 0, the ones that depend on x. And so that's ultimately the answer. So anyways, I hope that this walkthrough has been helpful in understanding how to solve this indeed tricky limit. But again, don't worry, because ChatGPT did not get it right on its first attempt too. Till then.